Just a brief note, we actually had a last minute scheduling change. So a slot opened up and, I thought I'd ask for, there's a data scientist who I've known a long time. I think she's a great data scientist and dare I say, very attractive. Who's that? It's me. How did I do that? I don't know. Okay. All right, here we go. Yeah, bringing the fun vibes to the end of the conference. All right. So as a young data scientist, I had a dream, and that dream was that I could write code and I could deploy it for other people to use. I literally the first year I was out on the job, I'm like, man, I wish I could take this code and put it in a place that could be run by everyone all the time. Is this sharing? It's recording. Okay, cool. It turns out this has been way harder than I would have expected. Spoiler, something's gonna make it easier, something in this talk, but this has been really hard. And I really wish my whole career there's a nice way to do this. Maybe you have fallen into one of these cases. Maybe you have made a shiny dashboard that you want to just put somewhere that anyone can use, right? No expertise, not even installing R, they just view the shiny app. And that conceivably should work because it's basically hosting a web page. Maybe you've made a model that you want to host as an API, so your engineers can call that API without knowing anything about data science, R, machine learning. Maybe you even just have an R script that you want to automatically run once a day, and you don't want to log into your laptop and hit run. And maybe this is something you want people in your company to interact with, but maybe this is a public-facing shiny dashboard, right? Maybe this is something for the, you want anyone on the internet to be able to use your shiny dashboard. Well, first off, how many people in the audience have ever experienced one of these moments in their career? Yeah, everyone raised their hands. So this is a real, participants, thank you for raising the audience. Yeah, everyone raised their hand. And I would just like to point out, this is different from, I want my coworkers to run my R scripts. This is I want someone with no expertise to be able to interact with the Shiny app or the Plumber API or whatever I made. So the idea of this talk is you want your code to run somewhere else. And how are we going to tackle this? So there are actually a bunch of ways you can solve this problem, and we're going to walk through them before getting to the punchline. Option 0, I would say, is you pay another company to manage this problem for you. One common solution to this is Posit Connect. Posit Connect lets you take Shiny apps, R scripts, whatever, and host that. They host that and they manage it for you. The talk this morning, Azure ML, I would argue is one of these sorts of products as well. And the idea is this is a very nice product for you as a coder because it's a nice UI. You can upload your Shiny app, you can manage it. The tool manages your permissions, things like that. So you don't have to worry about any of the overhead. Couple cons with this though. One, sometimes these cost a lot of money. Maybe you don't have that kind of money. Maybe you're doing this as a personal project. 2, a lot of them have limits on the number of users who can use it. Oh, only 20 people can get licenses, or even, maybe it's you have to create an account each time. That doesn't work if you want to host an app that anyone can use. Oftentimes you still need an engineer to set this up and maintain it. And so your company may not have someone who can do that. And also a lot of times with these solutions, you can't make it accessible to the public, right? If you make a Shiny app, maybe you want everyone in the world to be able to interact with it, but with these sorts of managed things, you can't, usually. So that's option 0. So let's go to option 1. You can run a Shiny R whatever code on a computer you own. Right? So that is a computer that sat in my closet and I hosted actual things on it for a long time. Yeah, if there's one takeaway I want you all to take away from this talk is that you can actually take a computer you own and put a Shiny app on it and have anyone on the internet actually connect to it. That blew my mind. That was crazy. I didn't realize that for a long time in my career. All you have to do is you have to take your code, the computer, you need to go to your firewall, open port 80, take your router and say, router, make port 80 go to this computer. And then you just change your Shiny app to have a couple extra commands. And boom, you are now hosting a web page in your house. Pros, this feels like regular coding, right? You know how to log into a computer. You can connect a keyboard and a monitor, and you can just do what you're used to doing. And pros, it's right there, right? You know that computer is working because you can see the little light on it. Cons, one, you might have a power outage. You might kick it. Your computer, you might spill coffee on it. I don't know. And your IT department hates this. Like, do not do this. I've been at companies that are very large where people do this, and it is just terrible. Do not do that. But if it's like your own personal website, go nuts. You're your own IT department. So that's option one. And again, this option works. And again, just keep that in mind. Option two is you pay a cloud provider to have that computer for you. Now that computer is not in your closet, it's in Amazon's closet. So there's a number of different names for this, depending on which platform you use. The maybe one you've heard of the most is an Amazon EC2 instance. This is the exact same thing as what's in your closet, except Amazon has the computer, and you have to just remotely log into there. I've been talking all day, as you guys notice, into there. And so that's, again, kind of cool because it still works like a regular computer. If you're used to Windows, you can use remote desktop and you like see the icons, you see the start button. And unlike your computer at home, it is always on. Or if it turns off, that means something far more tragic has happened and people won't notice. The cons is these companies charge you a lot of money to keep those servers running all the time. So if you have a computer that's always running in your house, that's practically free, but it can be like 20 bucks an hour, depending on how big the computer is. But I would argue a bigger problem with this is every time you want to host like a new Shiny app or anything like that, you need to spin up one of those computers. You need to install R. You need to install the libraries. You need to put the packages in. You need to make sure it's the right version. And then every new Shiny app, you have to do that all again. And you have to keep track of all these things yourself. And that very quickly becomes unmanageable. So that's option two. Option three, well, what if I told you, there's a punchline here. What if I told you that there is actually a way that you can set up one of these machines to keep track of every step you use when you're setting up the computer? And not only does it keep track of all the steps, but it'll actually store a snapshot of what the computer looked like after you apply that step. So you can kind of like run it partially. A system that actually lets you run these snapshots just at like one typing of a command, and in a way that an engineering team can understand. So you could take one of these things, pass it to an engineering team, and they can handle it using their systems. Surprise, that's the point of this talk, and that's containers. And I don't know why, but like every time people talk about containers, they put a container ship. So here we are, there's my obligatory container ship slide. Cool, so what is the basic idea of a container? There's three concepts I want you to keep track of. One is an image. So a Docker image is one of these snapshots. It contains like a fully working set of information that runs like a computer could run with. But images are built on top of other images. So you may start with an Ubuntu image. You then may install R on that, thus creating a new image. And then you may install your packages like Shiny, and that's a third image, like by stacking them all together. So the idea is you build an image by taking images and stacking more layers on them. To keep track of that, you have a Docker file. A Docker file is a text file that lists all the commands to build the images. So it's like each step in the process is in a Docker file. And then when someone says a container, that means you took one of those images and passed it to a computer and it is now running that image. So the difference between an image and a container is the image is like the snapshot. The container is the running computer that has that system. A lot of times people used to call this Docker, but Docker is like a very specific like copyrighted name. And now people generally say containers. The pros of this system, this is a basically universal language for engineers. If your company has an engineering department, they should be able to take a Docker image from you and do stuff with it. The pros, it can be saved forever and still run. So if you have an image that's built, you can keep it somewhere for like 10 years and it will then, if you use it again, it will run in the exact same way. So it's very nice, like archival system, you know it's gonna work. And you don't have to worry about what's on the computer that's running them. So like it's all contained with that system. Some cons, one is you actually have to get used to these, which is probably why most of you in this room who haven't used Docker, probably is why you haven't used it, because you have to learn a new system. And two, this is maybe a little bit more nuanced, but it's ephemeral, meaning if the container shuts off, you lose all of the information that was in the container. So it's really for a system that you want to go on, you want to do stuff, but then if you turn it off, the stuff inside's gone forever, which again, that actually rules out a lot of standard R use cases. Right, okay. And so just a little bit more on why engineers love containers is a container can easily scale. So if you make an image and you start a container on it, you can run it, but then like, oh no, memory limit, like fine, no problem. Just run it again on a machine that has more memory or more CPU. So you can use a bigger computer without changing any of the stuff that's on the computer. And this one, like people care about more in tech, is you can run these containers in parallel. So if you're like hosting a Shiny app, you can have 1,000 of the exact same app running concurrently so that, even if a lot of people are using it at once, it still doesn't crash. And I think that's big for us Shiny users, because if you don't do this and you just have one Shiny app and like 5 people try and use it, you probably will notice it quickly slows down. This is a solution to that problem. And now I'm going to show an example of how to make a container run a Shiny app. This is going to have 3 files. One is going to be an app.r, which is a Shiny app. It's going to be the most boring old geysers, whatever app. 2, it's going to be main.r, which has the run app command, which is it's a script that you run it, it starts your server. And then 3, there's going to be a setup.r script that installs the packages. So first, I'm going to take a Docker file, and this is going to be the thing that tells how to make the Docker image. First, I'm going to use this from command to say, take an image that already exists, and that image that already exists has the tidyverse on it and R version 4.4.1. There is a group of people called Rocker, and they maintain all of these R images. So you will always, you can just use their work and you don't have to worry about installing R, installing tidyverse, all that stuff. You just start with one of their images. Next, we're going to copy the code or files from the repository into the Docker image. Then the next thing is we're going to use the run command, where you can run Linux commands, and we're just going to run that setup script to install the R libraries. And then the very last command here is we're going to say, when the container starts, what do you want to have happen? And in this case, we want to run the R script main.r. So to take the Docker file and actually make the image, on the command line, we're going to run docker build -t shiny docker. Basically, this is saying build a container, build an image, and call it shiny-docker. That's the name of the image. Once I've built the image, I can then run it by using the docker run command. So basically, it got some arguments. You don't really need to worry about them, except this P8080 says, when the container starts running, pass the web traffic to it. And specifically, we're going to run the image of Shiny Docker. And then if you go to a website, you will see it. And now it's time for the live demo. Woo, let's hope it doesn't mess up. Woo, okay, here's our Shiny Docker container. So this is a repository. You, at the end of this talk, will be able to download this repository. In it, I have 3 files, that app.r, which is a boring Shiny app, right? It's our old faithful. Main.r, which is just the run app command to say start the Shiny container, or Shiny server, or Shiny app. And then setup.r, which installs the R packages. In this case, it just installs Shiny. I have my Docker file, that is the thing I just showed you, which starts with tidyverse, adds the files, runs the setup script, and then sets the entry point for when the container starts what to do. So I'm going to go down here to the command line, and I'm going to do docker build. And so what this is doing is Docker, and Docker is running on my computer right here. Like Docker is a program running in the background. So here's Docker. Docker is going to download that tidyverse image, add the files, run the setup script, and set the entry point. If you actually look at the commands, it's actually like running and copying, like it does all the things I tell it to. And then I'm going to do Shiny Docker run, and this is actually starting that image as a container. It's going to take a second to start up because it needs to like start R, but then it actually gives you the same output as if you were running R, where it says loading package Shiny and then listening on the port. So now, just to prove a point, if I go to 17.0.1, there is my old faithful geyser data. Now, now hold on. First off, this would have worked if I wasn't on the Wi-Fi. I would show this to you, but then the recording, like they stopped for the virtual people, so I'm not going to do that. But can you all trust me that this would have worked? You guys plausible? Yeah. Okay, which leads to maybe a startling point, which is you just ran Shiny on your laptop. Why should I care? I just did something you can already do in a more convoluted way. Wow, what a good use of a talk. But you guys ready for this? R isn't installed on this laptop. Everything I just did, I did on a computer without R on it. I would drop this mic if it didn't belong to the University of Washington. Thank you. I hope that would get a good reaction. All right, but I'm not done. You guys all ready to have your mind really blown? This computer is a Windows computer. That Shiny app is running in Linux. What? It's running Linux on Windows. Whoa. I'm going to put it out. I'm going to put out the, yeah. All right. All right. So what is this actually happening? Is a container is a totally isolated system from the system that's running it. It doesn't even have to be the same OS. And the image is going to stay the same forever. So I can take this Shiny container that's running on my laptop. I can rerun it in 5 years, and it should all work, whether or not I have R installed. This is a very powerful idea. There are downsides to it, but like the idea that I can make a totally isolated thing and it just works regardless of the system it's running on is pretty huge. So let's take this baby to the cloud, right? If you can have it running on your laptop, why not take that image and have it run on Google Cloud? So there's a bunch of places you can run the container. By far, the thing I find the easiest is Google Cloud Run. Google Cloud Run is a service that just takes your image, runs it as a container, and it will like correctly turn it on and off, and it'll spool it up, and it will do all of the stuff that you want for you. All you have to do is pass it an image. So the way you do it is you do this command docker push. So on the command line, just like I was doing docker run, docker build, I can also do docker push, and that will push it up to the cloud. And then I can tell Google Cloud Run to deploy that image as a container. You set what image to run, you set how much concurrent users, whatever. And now you have a lot of concurrent containers running the cloud. So here's another live demo. So this is, I did this, is my Wi-Fi on? Yeah, great. So I did this last night. I was up too late, which is why I'm talking so silly today. I did this late last night. I just uploaded the image, and I started it on Google Cloud Run as this Shiny Docker image. So it's actively running. I can see metrics, and importantly, it has a URL. So that URL is the URL for this app. And I've set that I can have up to 1,000 concurrent containers for this one image. Which leads me to the very next point, which is everyone right now, scan that QR code. You will get that Geyser app. You will not break it. People on virtual, you try this too. I'm pretty sure this will work. I'm going to try it on the screen. Here, we'll all follow along. So this is, I made a bit.ly link to that URL. It's going to take a second to start because it has to start all these concurrent containers. And just, I heard some people thumbs up if it's actually, yeah, all of you are thumbs upping. Well, maybe not all of you. Anyways, it's starting up the systems. If we go over here, I bet if I go to metrics, we will see a huge uptick in the, it might be a couple seconds delayed, but in theory, the container instance count should have just shot up. Yeah, it's a little bit delayed, but that's fine. You can see where I was testing it at like midnight last night. Oh yeah, so here, look, this is me. Now it's running here too. So basically Google just, I don't know how many people are in this room, Google just spun up 100 versions of that container and it all works. I challenge you to find another way that you can have a Shiny app run with this many users without having to worry about it. Again, this should blow your mind. It blew my mind when I got it working the first time. So the point is that if you want to take a Shiny app, a Plumber API, a script, you can take it, you can put it in Google Cloud as a container and run it all at once. And run as many concurrencies as you want. Oh, and also I should point out, Google starts and stops these containers whenever they're needed. So this is actually extremely cheap to run. If you go find like a hosted service, a virtual machine, they'll usually charge you like 20, 30 bucks a month at minimum. But this is basically going to cost me pennies a month because 99% of the time they're all going to be off. Only when everyone watches my video at once or whatever will it spool up. So is there anything a container can't do? So as I said before, one, it will not be a good way to hold persistent data. So if any of those containers stop, you lose all the data. So if your Shiny app requires you to have a bunch of data and whatever, it takes a while. And each time a container is running, it needs to repull all the data. So if your task requires you to have a long-term data storage, what you have to do is have your container, or your image, like every time the image starts, it needs to pull the data in. Two, it will not really let you interact with the R code. So if your container is running, it is extremely difficult to get in there and see the R code that's running and actually like edit it or see what the variables are at that moment. Like it's a kind of isolated thing, which means it won't really let you pass code between humans, which my understanding is our next talk is about. Like this is not a good solution for that, because the moment it becomes an image, it's basically like a block of thing. Like you don't edit it after that point. So if you want to pass code to your coworkers, the moment you pass them that code, I bet they're going to want to edit it. And a container or an image is not good for that. An image is really good for taking something, putting it into place. You can run a lot, but it's not good as a method of communication. Like an image is not a thing you just want to send your coworker. The best thing you can do is send them the repo and make them build the image. But like the point is, it's not really good language for human to human interaction. And lastly, you might go online and you might read about Docker for data scientists, and you might find a blog post where, you know, reproducibility of your analyses, the idea that like, hey, a year from now, you want your analysis to be able to run again. That's like a big problem in data science for a long time. And if you go read online about Docker, you might find data scientists saying, hey, you can make a reproducible analysis by putting it in a Docker image and then just saving that. And then anytime you need to look at the analysis again, you have the Docker image. This is not a good idea. This is an idea that is miserable. Miserable people have this idea, and if they tell you you should do it, they want you to be miserable with them. Don't do, like, it is a bad idea. This is the hill I will die on. It is a bad idea. If you're in this audience and you're like, Jacqueline, I think it's a good idea, come talk to me after. I will try my best to snap you out of it. It may not work, but like, don't do this. It's really just a good system for running things in like production settings. So that's kind of the big point of the talk, but I have an epilogue. What the heck is Kubernetes? This is a question I asked myself as a data scientist for a very long time. And basically, I showed you with Google Cloud the idea that, hey, you can run a container very quickly and like spool it up. But instead of using Google Cloud, suppose you had a company at your, or a department at your company to manage this. That department probably exists if you're a big enough company. That department's called DevOps. They use a tool called Kubernetes to manage all of these containers and the computers it runs on. So you think of Kubernetes as like the system that takes your images and runs them and scales them up and scales them down. In fact, I think Google Cloud Run on the back end is secretly just Kubernetes. I've been in the biz for a little bit. I don't think I know any single instance where a data scientist should be worrying about Kubernetes. If you are like, I need to know Kubernetes for this, that's probably not the right job for you. Or if you feel like you need to go use a system where someone else does it for you, it's just not worth your time. I mean, occasionally on LinkedIn, you see those like 10 skills data scientists need to know, and one of them's Kubernetes. More miserable people. Don't listen to them. Okay, so that is my talk. Thank you so much. You can go download the repo if you're so interested at this place. Thank you.